Alright, so I'm just going to go ahead and put example 9 up here since we were working on that one. And we can review each step we went over. So again, this one was centered at 1. And we had a little bit of combination of the little pieces we had already dealt with. We had a number on top, we had a coefficient in front of the x, and we have that minus 1 there. So we really didn't have anything that we could compare this to that we had memorized. So we started off by doing the Taylor series like we always would a couple of sections ago, taking the derivatives. They wanted 4 non-zero terms, so we needed the original and the first 3 derivatives. So that's why we had done that again. And we found those coefficients. Again, those coefficients were at the center of 1. So those are the coefficients for the Taylor polynomial. Once we plugged in the coefficients, we know the center was at 1, so we had x minus 1 everywhere. Again, that's the same pattern with the factorials, but we ended up reducing. So the 2 factorial and the 120 reduced, we just had 60 on top. 3 factorial and 720 just reduced, and we were left with 120 on the top. So that was the Taylor polynomial. And then right at the end of class, we talked about trying to find the general term. So we realized it was alternating, so we know there had to be a negative 1 to the n. So we figured out that part. We knew the center was at 1, so we know we had to have an x minus 1 to the nth. So we were okay with those parts. But I remember this was the part that we were having trouble with. So this is where we needed to look at the coefficients. We could tell the first coefficient we know was a 15. So somehow when we plug in n equals 0, we had to get 15. Then whenever n equals 1, we had to get 30. And then 60, and then 120. So if you look at 30 and 60 and 120, 15 goes into all of those. So we know we're doing something with the number 15. So we had the number 15 there. But then we realized this was 15. This was just 15 times 2. So 2 to the first power. Then this was 15 times 4. Well, 2 squared, and then 2 squared times 15. So that's where this term came from. And as you go on successfully, they all will fall in order there. So that's how we found the general term. Then we needed to go on to the interval. So again, ratio test, setting up the limit. So we need the n plus 1 term over the original term. Again, you can multiply by the reciprocal if you needed to, but in this one we got rid of the factorial, so we didn't have to worry about the reciprocal. So x minus 1 to the n plus 1 times 15 times 2 to the n plus 1. Again, it's absolute value, so that gets rid of your alternating term. So that negative 1 to the n, that goes away. On the bottom is the original to the nth power. And again, now you can reduce these fractions. We have x minus 1 to the n plus 1 over n, and then 15 times 2 to the n plus 1 over 2 to the n. So after reducing that, your 15s are going to go away. You're going to be left with 1, 2 on the top. And you're going to be left with an x minus 1 on the top. So 2 times x minus 1. Now again, all the problems, I know it's been a week or so since we've looked at them. This one was centered at 1. So we want to get the x minus 1 by itself. So we need to get rid of the 2. So if you divide by 2, you have x minus 1 is less than 1/2. So this less than 1/2 right now, the 1/2 is your what? What is the 1/2?
That's what, well, you subtract, so that's like going to give you your interval if you add 1/2 to the 1 and you subtract 1/2.
Okay, that's correct. That's how you're going to use it. What's this called? If they ask for this number, what's this number called? Because they didn't specifically ask us for this number in this question, but you need to use this number to find the interval. Yeah, it's the radius. We know the radius is 1/2, so you're going to use it exactly how Caitlin said. You're going to take and subtract it from your center and add it to your center. That's how you find your radius of convergence. Again, so we found the interval. Well, it's centered at 1. If you subtract 1, you get 1/2. If you add 1/2, you get 3 over 2. So the interval of convergence, 1/2 to 3 over 2.
Did we Did you test them?
You should test them. We don't have them tested in this example here, but yes, you should test them. So
I forget, what do we plug them into again?
you have your summation. You need to determine whether it starts at 0 or 1, but your summation of your nth term, and you plug in each endpoint to determine whether it converges or diverges.
And
So in this case, they diverged on both of them. We just didn't show it in this example. But if you plug it into this and take the summation of this, you would get diverges on both of them. We're going to do 2 more examples today where we're going to test the endpoints, so you'll be reminded of that, but that's how you do that. All right, so we did most of that problem last week. Do we have any other questions about this one? And again, the reason we had to go through this process is because this wasn't one that we recognized. It wasn't one that we had memorized. Okay. Now, after going through multiple examples of this, I think last week we saw where we had the 1 over 1 minus x, we have that memorized, and then we had little changes to it where we multiplied the x by something. Well, we could write down the original, and then we knew how it would manipulate from the original one we had memorized. So that's how that can be helpful. So be sure to look back at that too before the quiz after the next section. All right, let's go ahead on to example 10 then. All right, it says we can integrate or differentiate a power series to obtain a new series. When we do this, the radius of convergence will be the same, but the interval may change. In this case, we must retest the endpoints. Okay, so example 10. Find a power series that represents 1 over 1 minus x quantity squared, centered at c equals 0. Hint, what is the derivative of 1 over 1 minus x? What is the radius of convergence? Interval of convergence. So I wanted to mention, if an AP exam, they ask a question like this, they're probably not going to give you a hint and say, hint, take this derivative, see how it helps you. One way or most likely they would do this, is it may be an open-ended, and they would say, part A, take the derivative. Part B, do this. Part C, do this, and eventually it would lead to this. But instead of making it a long, drawn-out problem, in this one, we're just saying, hint, do this. But in a free response, they may just give that as part A, and you'll have to know to use that later in the problem. Okay. All right. So the hint says to take the derivative of this. So what is the derivative of that? Derivative of 1 over 1 minus x. Think about the whole denominator to the first power, and then think about how you would take the derivative. Anybody get it?
It's just what we need to make it the first power, then do like the chain rule. Basically.
Yeah. So bring down the -1. You keep the original, reduce the power by 1, and multiply by the inside, derivative of the inside. See, we get -1, or just a negative there. You don't have to write the 1. Times 1 minus x to the negative second power times -1. That's going to reduce to 1 over the quantity 1 minus x squared. Well, isn't that exactly what we're looking for over here? Trying to create the power series of that. So, if we look at this original one they gave us right here, the 1 over 1 minus x, don't we have that one memorized? 1 over 1 minus x? That's one we know, right? And remember, they're telling us it's centered at 0, so we know that one we had memorized was also centered at 0, so we can use it. So just as a reminder, let's write that one down. 1 over 1 minus x. Just in case you need the reminder, what is it? One over 1 minus x. Ahead.
1 plus x squared plus x cubed.
Yep. Okay. So 1 plus x squared plus dot 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 plus x to the nth. Okay. So that's the original. And they told us as a hint to take the derivative of the original, and that would give us exactly what we're looking for. So 1 over 1 minus x squared is equal to taking the derivative d over dx 1 over 1 minus x. So if I take the derivative of the one I have memorized, what am I left with? And again, we want I think we want 4 non-zero terms. Okay, it doesn't say here. Let's go to 4 non-zero terms, though. That's what we've been doing with each one. So 4 non-zero terms. What would be the first term? Again, I'm taking the derivative of the one I have memorized. So what's the derivative of 1?
0.
Is that a non-zero term? No. So we can't include that one. So let's go to the next one. Derivative of x.
1.
1. Derivative of x squared.
2x.
Plus 2x. X cubed. Derivative of that.
3x.
3x squared. We have to go one more term. X to the 4th. Derivative of that. Yep. 4x cubed plus dot dot dot. How do I write my nth term? This one's going to look a little different than up here, but again, use your derivative rules to help you rewrite it. You think you have it, Abby? Give it a try.
1 times x to the n minus 1.
Exactly. Again, just use your power rule. Bring down the power so n's in front to the n minus 1. That's exactly what you did. So n times x to the n minus 1. So we've created our new power series. Now we just need to find our radius of convergence and interval of convergence. So, like we've done before, we're going to do the ratio test. Limit, absolute value. Again, it's the n plus 1 term over the original. So we're going to have n plus 1 x to the n, because remember this is n minus 1. If you add 1, it's just n, over n times x to the n minus 1. That leaves me with absolute value of n plus 1 x over n n plus 1x over n. I'm just going to be left with the absolute value of x. And again, with the ratio test, we want that less than what? We want that less than what? We want it less than 1. So again, our radius, again, nothing's with the x. It's centered at 0. Up above, we had that centered at 1, so x minus 1 is what we had here, but centered at 0. So x is less than 1. Radius, they specifically ask this time for the radius, so you need to state radius is equal to 1, because they specifically ask for it. We're centered at 0, so we know the interval is going to be 0, -1, 0, +1, so -1 to 1. I'm going to erase a little bit so I have room to check endpoints. I'll leave that much there. Okay, so I want to check -1. So this goes back to the question you were asking, Caitlin. How do we check those again? Summation of n, and it's going to be x to the n minus 1, but we're going to use -1 to the n minus 1. And where does that start? N equals what? Think about that nth term. I erased everything except the nth term, but you could look at your paper. You have the whole series there. What value of n should we be starting at? Zero or 1? Anybody can answer. Should we be starting at 0 or 1?
1.
1. Because the 1 minus 1, that gives you 0. X to the 0 gives you 1, and this is 1, so your first term was 1, so that makes sense. Okay, so 1 to infinity. So we're taking the summation from 1 to infinity of n times -1 to the n minus 1. Converge or diverge? Converge or diverge? Diverge. Okay, and then for the next one, you can write it so you have the steps, so when you look back in your notes, but I'm not going to write it all out. It'll be the same summation, except instead of -1 here, it's +1. That's the only difference. When you take that summation of with 1 to the nth there, that would also be diverging. So again, to answer your final question, they wanted to know the interval. So they asked for the radius, we have that, and they asked for the interval of convergence, and we have that also.
What would make it converge? Like in this summation? Is it just because it's like?
Well, we may see that in the next problem if you want to. And again, when you're checking those endpoints, you can think back to any of those tests that you know. Any of them that you know, you can use those to determine whether it converges or diverges. You don't have to just use ratio test for endpoints. You don't have to just use nth term test. Anything that you can see that applies from all those tests, you can use any of them to determine whether these endpoints converge or diverge. Okay? So you're not restricted on what you can use for those. Does that make sense?
Yeah.
Okay. Any other questions on this example 10 so far? All right, so that about wraps up for example 10. Once you, again, take the derivative, you realize that that's exactly what you're looking for, so you just need to modify or take the derivative of the one you have memorized. All right, let's look at example 11. Find a power series that represents ln of 1 minus x, centered at c equals 0. Hint, what is the integral of 1 over 1 minus x dx? Then what's the radius and what's the interval of convergence? So they want to know what is the integral of 1 over 1 minus x. So what would that integral be? What is the integral of 1 over 1 minus x? Any ideas out there?
Basically, you just take the integral of each term, like we did, other one we did derivative of each term, but now take the,
Eventually, we're gonna get there.
isn't it ln or like the first one?
So that's, yeah, I'm looking for the integral of this, ln of what?
1 minus x.
Okay. So that's really close. If you are just given ln of 1 over x, if you take the derivative of this now, what is the derivative of this? Take the derivative of this, see if you get 1 over 1 minus x. Is that what you got? 1 over 1 minus x exactly when you take the derivative of that? It's not exactly what I got. So, what's the derivative of 1 minus x, the inside?
Because there would be
You get a negative, so we have to have that correction factor with the integral. So really, if we take the integral of 1 over 1 minus x, that gives us negative ln of 1 minus x. Make sense? Now if you take the derivative, you would get the negative x times the negative gives you positive 1 over 1 minus x. So we know the ln of 1 minus x is equal to the negative integral of 1 over 1 minus x, because that correction factor, dx. So now we're going to go and start doing what Caitlin told us we needed to do. We have that negative, we'll worry about that later. We're taking the integral of 1 over 1 minus x. Again, we know what 1 over 1 minus x is, and we're centered at 0, so we're all good to go on with that. So, think about, and if you want to look up from up above, you had it written up above. I think I erased it. Yeah, I erased it from up above, but you should have 1 over 1 minus x written in the example above. Look at each individual term, and let's take the integral of it. So, integral of the first term, what do you get?
x.
Second term. Third term, we're going to go to 4 terms. Anybody? Go ahead. 1/3 x cubed. And lastly, the same pattern, 1/4 x to the 4th. Plus dot dot dot. We need our nth term. In this case, look at your nth term from the one you have memorized. Take the integral of that nth term. So what is your new term?
N times x to the n plus 1.
Close. You do have x to the n minus 1. And if you think about this as division, not multiplication, which you can think of it as either, what are you dividing the x to the 4th term by, or x to the 3rd term by? What are you dividing by? What would be on the bottom? Sorry, this is x plus 1. Sorry. X plus 1. What is on the bottom? So you're saying n plus 1 is 4, and then you're going to divide by 3? Yes. n plus 1 is also on the bottom. Okay, so we're getting closer. Now, we had that correction factor because of the integral. We needed the negative. So we really have negative x minus 1/2 x squared minus 1/3 x cubed minus 1/4 x to the 4th minus dot 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 minus x to the n plus 1 over n plus 1. And that is our power series. Are we okay with how we found that then? Again, the one we had memorized, centers at 0. So last step, we need to find radius and interval. So ratio test again. Limit as n goes to infinity. Absolute value. So we need to do the n plus 1 term. Well, remember, it's already n plus 1. So what's n plus 1 plus 1? Well, we have the n plus 2 term. So n to the x to the n plus 2 over n plus 2. Again, multiplied by the reciprocal, n plus 1, x to the n plus 1. Lose anybody? No. Okay, so now we need to try to reduce. We're left with, well, this one we're left with an x on top. And n plus 1, n plus 2. Again, if you think about those n's going to infinity, they're going to cancel out. The plus 1 and the plus 2 really are not going to do anything in the grand scheme of things. So you're left with x. Again, less than 1 because it's a ratio test. So they are specifically asking for radius. So radius is equal to 1. Okay, so we found the radius. Let's look at our interval. We know we're centered at 0, so negative 1 to 1 again, but we need to check our endpoints. So summation, n equals 0 to infinity. This one would be, we need to take this term here, negative 1 to the n plus 1 over n plus 1. Okay, so negative 1 to the n plus 1 over n plus 1. Converge or diverge, and why do you think so? So try to think back. Caitlin had asked about this before, but think of all of your tests now. What test do you think applies this? Run through them. Think of the test that we went over. I mean, we had multiple tests. Which one do you think can apply to this to determine whether it converges or diverges?
Alternating series.
Yes, alternating series test. So now you need to try to remember how the alternating series test went to test this one.
That one.
So now you need the alternating series. So we know we're going to be dealing with alternating series test for this one.
Okay, so you do like the nth term test first. Don't you do like the nth term test of 1 over n plus 1, and if it equals 0, then it converges?
There you go. If it decreases to 0, does it decrease to 0? 1 over 1, n plus 1? As you go to infinity? Yes. So that one does converge. Converges by AST. So that's why these tests are always going to be coming back. They're not going away. You have to memorize them. All right, let's check the other endpoint. Summation, n equals 0 to infinity, 1 to the n plus 1 over n plus 1. Is that an alternating series? No, you can't use the alternating series now. So you have to think of other tests that may work. Do you think this one converges or diverges? So if you think about the top is always going to be what? It's always going to be 1. So you have 1 over n plus 1. So use that information to help you determine how you think you could test this one. I see some gears turning out there. I think I heard some conversation about doing a comparison test. Were you thinking of direct comparison? Or not sure at this point?
Direct.
Okay, so if you do direct comparison at this point, you tried to compare it to what?
1 over n.
1 over n, which is what I would choose too. But 1 over n plus 1 is, it is not, let me try to think of the word. 1 over n plus 1 is not larger than 1 over n, it's smaller.
Yeah,
And you got 1 over n to diverge, so it couldn't tell you anything.
Yeah.
So you can actually go about this one by the limit comparison test. And you can go through the process if you want to. We have a few minutes left, but I'm going to tell you after doing the limit comparison test on this one, you will get it diverges. Again, it may be good practice for you to try that, but by the limit comparison test, that one would diverge. So we found the radius. I had that circled over here. The interval would now be -1 with a bracket to 1 with a parenthesis. Again, because -1 converged, 1 diverged. Okay. Help now that we saw one where it converged, Caitlin?
Yeah,
All right, I'll leave that up there for a few moments. We only have a few minutes left, so that's where we're going to stop for today. And again, we'll go over the last two whenever that time may come.
Actually, we're done for the week. I